Okay, so here's a quick example of just in real time of how it is to waterproof something. And here I want to show you an example of some things. This is a simple rooster stick. Majority of times we can open these up, but we could just add the solution through the inside, dry it out. These get hot, so they'll dry themselves out. And actually, as it gets hotter over time, the baking will occur and be much better. HDMIs in and out. We just add solution in there, protects the coating over time. Here's a board, real simple board, nothing special about it. There is a, I don't even believe there's any connectors to this one, so this will be done. And this is another board. This one does have some functionalities, buttons here and there, and all that will be fine with the battery, connectors, LED light, and all this will be taken care of, so nothing will damage it as well. But this is what I wanted to show you, this particular one. This one here, as you see, is sandwich. A lot of inner parts in there, can't really get in there. This side has connections also as well, HDMI. So there's a lot going on in here. It's a very powerful PCB. So you notice it's very difficult. So the problem with this one is, in most applications, what everybody's using is conformal coating, which cannot get in underneath here, underneath or around it very much. So, and on top of that, you can't put stuff into those small pins in here, if you notice. Let's see if we focus real quick on it. And so it's very difficult to get in there. So this is a perfect example of why we're going to do a sample test on this one. Of course, you can always coat HDMI ends by just doing the process. Now, what are we doing here is we're taking a product here, NanoFlowX, and this particular one is V2. There's other higher ones and lower ones, so the V1 through up to 5. And what this does is, this particular one is going to conformal coat, so in a sense of say, better than conformal coating, because this is going to be a liquid dip application. Now, many devices require, when you get a product like this, you have to mask off a lot of areas, including here and there, because if it gets inside, it won't work, it won't connect. They're too thick of a solution. With a NanoFlowX, the solution is so thin that it's going to bed itself inside every crevice under microscopic levels inside the board, which may look smooth to you, and is not. They're like Grand Canyons under the microscope. And so with that, we're going to fill all that up with the NanoFlowX, and also going into the pins and the little mini HMIs, and without masking it. So all the solution is going to go in there, and then whatever you plug it into, it's still going to work just fine. Okay, so the way to start this, again, as we say, liquid dip situation here, we're going to go ahead and start this application. We're going to put inside a glass bowl. Now, this can be done in any level size of electronic, as long as the bowl will be able to fit it. And as long as when you fill it up, it goes surpassing the top of the electronic board, okay? And in this case, we're going to use some gloves, even though it is safe. It just, anytime you mess with chemicals, whether it's cleaning material chemical, or whether it's this type of chemical, it doesn't matter. Always wear gloves for safety reasons. Eye goggles too. Respirator mask if you want. You should if you're going to be doing large times amounts. And when we treat it and add the solution in, we're going to dry it. And a typical heat gun will work just fine. A lab oven is even better. I got a cup of water here with the droplet to give it the test when we're done. Okay, so we're going to go ahead and apply this. So what we want to do is we want to go ahead and put that in there. Now, I just barely made it just to the top and not enough. So I'm going to add a little bit more. There we go. Now, I'm completely submerged. Now, this is a liter. Is normally what it's purchased for. I can do a liter of this, hundreds of these items in this size, hundreds. And the bigger the board, obviously the solution is. Now, you don't even need this much time in there. Matter of fact, we're done. That's how fast it was. So it got into everything inside. And you want to lift it, put it there like that, shake it out, Now I like to use something to put it on. To understand how to treat it here, I'm going to put it on a board. Okay. Now this solution that I just used can be put back into the solution. I'm going to put it inside this jar though. Oops, and that's why I have plastic. The idea is not to really spill anything the way. Unfortunately, that does happen once in a while. And that's why it makes it a lot easier to go from glass to glass. Now, we do use glass, not plastic. The only time I ever use plastic is this funnel. And because this funnel's already been coated repeatedly with the solution, it's not going to stick any more to it. Now, unfortunately, I did lose some there. I'm just going to get it, kind of wipe it down just a little bit. It wasn't that much. So here, I'm going to put a heat gun. Now the heat gun, if you notice, it gets warm, say about this type of distance here. I want to say that's a good, I don't know, 10 inches there, 12 inches maybe there. I'm going to take these gloves off so it'll melt on my hands. And the heat gun warms up, I'm going to go ahead and apply some heat. Now remember, this is all done in real time. I'm going to go to the back, the top, the front, the sides. And I don't want to concentrate in one spot too long. I'll put it there. On the sides. On the other side. Now we are done with that part. Now normally when I want to cool it down, I usually have a fan next to me. I'm going to go ahead and put this next to the fan to get it cool. Does it kind of cool it down? Let's get in there already. Now you notice it was just a matter of seconds, 5 seconds basically to submerge it. You can take it out. I don't touch the top part, only the sides of the board after that point. Now here's where the test comes into play. Okay, this is water. I take a droplet. Okay, now I'm going to put it here. I'm going to go ahead and add a droplet. Now you notice that water now is moving very freely. That's basically what's happening. The board just became immediately hydrophobic, even on metal, by the way. It cannot stick to anything. It literally runs off everything. So let's try the other side on this part here. Now you notice how it turns into a ball? That's basically is telling me that sphere there is coated and falls right off. Let me try this side here. And basically it's in there. See how it acts like a magnifying glass now on those numbers? Hope you can see that better. And as it moves around, and now it's basically hydrophobic. And that's basically, you could do that with all electronics, no matter how big the electronic board, or how thick it is, how many components, whether it has plugs, ribbon cables, connectors, buttons. It all could be coated in one shot. And basically that's the way NanoFlowX basically works. And so drones are a real big deal because now it eliminates the humidity, moisture, corrosion, salt air damage. Many times these drones are stuck in locations that are not, how should I say, climate controlled, and so the moisture will get on the boards and destroy the electronics just by sitting over time. This will be eliminated 100%. Also, if you notice of some stuff, they have that fuzz that grows on electronics after a while. That will be eliminated as well. So if you have any other questions, just reach out to me. We look forward to doing some business together. And NanoFlow has been around for a long time, dealing with military, aviation, automotive, the home automation industry, many different industries out there. If you have any questions, go ahead and reach out to me. Thank you.